Hello, my name is Greg Slobodkin. I'm with 1105 Public Sector Media Group, publisher of FCW and GCN. I would like to welcome you to today's webcast, Mocking Reality, the Power of Service Virtualization, which is sponsored by IBM. In today's webcast, you will hear about a large government agency that was struggling to provide stable test environments to support their partner landscape. The challenge, as you'll hear, for this agency was that duplicating production using traditional methods would have resulted in infrastructure cost blowouts, misalignment issues, and resourcing issues. As you'll hear from our speakers, the problem came to a head when the department embarked on a large program to transform the B2B data submission platform. The agency turned to service virtualization to simulate the department's core systems, removing the need for the use of real systems in testing and reducing the need to secure expensive infrastructure. This webcast will examine the challenges and successes involved in the program. Our speakers and subject matter experts for today's webcast are Ting-Ting Chang, IT architect for IBM's Global Business Services, who has been with IBM for more than 10 years. Ting-Ting is a jack of all trades, having also had roles as a solution designer, business analyst, process modeler, developer, war room negotiator, consultant, and general problem solver. She has been involved in the delivery of projects in telecommunications, banking, government, retail, and utilities industries. Her recent engagements have led her to become one of the Australian experts in the test virtualization space, having designed and implemented virtualized services using the two leading test virtualization products in the industry. We're also joined today by Andrew Bentley, technology architect with IBM's Rational Software brand. In this role, he works with customers to realize enhancements in their software supply chain. As a 17-year veteran with IBM, Andrew has worked as an architect and technology subject matter expert with a range of public sector, telecommunications, financial services, and mining and industrial companies. He has contributed to IBM's intellectual property via white papers and IBM Red Books and filed for his first patent in 2013. Now, before we get started, I want to go over some housekeeping items. At any time during the webcast, if you would like to submit a question, just look for the Ask a Question console. There will be a Q&A session towards the end of the webcast. As a reminder, please turn off your pop-up blocker before the start of the presentation so you can optimize your viewing experience. And we also recommend that you enlarge the slides on your screen to make them more viewable. Finally, after this session is complete, we will be emailing to everyone a link to the archived version of this webcast so you can view it again or share it with a colleague. And now, I'd like to turn it over to Andrew from IBM.
Thank you, Greg. Welcome to this session where we will explore one customer's journey with service virtualization. Just for your information, this is a repeat session that was given at IBM's Innovate 2014 Technical Conference. We start, as usual, with describing the nature of the problem. Shortly after IBM announced its intention to acquire Green Hat, the company, the Rational team here within Australia started working with a large government agency around their testing and environment practices and how we believe that service virtualization may be able to assist. The agency's transactional IT landscape was quite complex and a multi-tier environment where applications interfaced with their existing e-commerce presentation services. As a result, how do you replicate a test environment when you need to test applications which are up to 6 applications were involved in a single processing interaction, as well as the transaction may needing 13 different hops between these related applications. In addition, where the specific environment had high-level non-functional requirements around high availability, redundancy, and the requirements to be able to load balance systems to improve this availability. In addition, the complex nature of the application environment also contained a number of core processing systems on mainframe services. Service virtualization, as we will see, can help in these circumstances. To gain a little more understanding of the customer's landscape, it contains over 5,000 operating system images, or OSIs, of which, roughly speaking, 3,500 were non-production systems. It can take up to 200 days for a project to receive their desired infrastructure after requesting it. These numbers were borne out by external consultants. In addition, they undertook one major release per year with many other smaller releases related to fixes that may need to be applied during the year. The technologies involved in this environment were multi-tier application architecture, complex NQ, message broker XML architecture, a range of web services at the front end, and of course the IBM System Z-based KIX COBOL back-end core processing systems. Each new project requests a copy of each of these key systems for the life of the project in multiple levels. And as a result, configuration drift is a major problem in the environment management teams. Due to the lead time for components to be made available, project commencements were regularly delayed. The customer essentially has 5 different levels of environments associated with their software development lifecycle, starting at development, string test, systems integration test, performance test, EVTE, which we will describe later, and finally their production environment. The EVTE environment is also made available to third-party software developers to test their own products against these agencies' core target systems. For each release, these vendors must certify their software to ensure endorsement by the agency. This diagram describes the application component architecture of EVTE. We can see a range of components involved in the transaction, such as security access control systems, represented by Vanguard and Access Manager, back-end mainframe systems, represented by ICP, EMC, IPS, AIS. All of these are acronyms for those applications. We can also see core messaging protocols for the data interchange, XBRL, HTTP, and MQ-XML. For those that don't know, XBRL is Extensible Business Reporting Language and is a standards-based way to communicate and exchange business information between systems. It is an XML-based standard and uses taxonomy and metadata to carry definitions and relationships contained within the message. This was the target environment for which the IBM Service Virtualization platform was used to replicate. The existing EVT environment was not meeting the customer's expectations. With costly support structures, the environments regularly becoming out of sync with production systems, a substantial lack of stability in the service, and whilst attempts had been made in the past around handcrafting mocks and stubs associated with some of these systems, there was limited success because of the coverage of data and scenarios was limited. The handcrafted mocks and stubs themselves were difficult to maintain and did require, in certain circumstances, a range of specialised skill sets and or business knowledge to truly understand how the processing of these systems was undertaken. As a result, the agency's customers, the third-party software developers, were extremely frustrated and a new way was needed. The need for change. As part of a reform agenda, the agency undertook a major redevelopment exercise to transform its platform. This involved a new electronic channel exposed to businesses and other parties which needed to be flexible and maintainable, seamless and transparent, as well as robust and scalable to meet the high demand processing requirements expected of the new platform. Part of this redevelopment exercise meant that EVTE needed to be stabilised and enhanced to allow development activities to be carried out by not just the agency, but also the third-party industry software suppliers. And so we come to mocking reality. IBM's service virtualization technology through Rational Integration Tester and Rational Test Virtualization Server provide a platform to support development and maintenance of virtualized services where services are not yet developed, where services may not in fact be available in any given environment, or there are high costs or difficulties in providing these services. And finally, where difficulty may exist in the establishment of testing scenarios due to data or other constraints. With this agency, RTVS was the key to stabilising the EVT environment by removing the dependencies on live interfaces. These virtualised services can be created from sample messages or WSDL and schema definitions, or directly recorded. These virtualised services can replicate the live systems and supply various responses based upon a range of input data being passed. We now see our previous component picture showing the scope of the virtualised services implemented using the IBM service virtualization technology. We see that the vast majority of services, vast majority of systems have a virtual service representing them in the EVT environment, supporting the development and testing needs of the agency and their third-party software suppliers. I would now like to hand over to Ting Ting, who will take us through how success was achieved.
Thank you, Andrew. How did we achieve success? So firstly, I'm going to speak about the team that built the stubs for the government agency. It was actually quite a small team, a core team of 3 people. It was myself as an architect, and the 2 test virtualization specialists actually were testers and business analysts as their background. The 3 of us installed, configured, and upgraded all the RTVS components in all the environments, and we supported them throughout the whole development and build process. Over the course of 8 months, we have built around 25 mock or stubs from basic to advanced complexity. These stubs support 6 environments. As Andrew had referred to earlier, we had lower level environments which were development and string tests, system tests, and of course the EVT environment itself. We also did the requirements gathering and designed the scenarios for what we consider 3 different user groups. Apart from the external software developers who use the EVT environment, RTVS itself was used to support the core platform, which was being developed at the same time. So through that development of this agency's platform, the developers and testers were able to use our stubs as well. This team also trained the customer team for their, to enable them to support the tool in future, and also to enhance the tool for further organizational-wide usage. Our RTVS team actually had no prior experience with this tool, and it's very limited development experience. I think that speaks to one of the advantages of the tool, that there is no need to use basically experienced developers to create complex stubs. the way we learned was through a 40-hour self-paced course and also 5 weeks of on-the-job training from an experienced consultant. And of course, we work closely with our software group counterpart, the Rational team, for any troubleshooting with the product or basically just learning the functionality of the product as well. So now I'm going to speak a bit about the deployment topology itself. And to do that, I may explain a bit about the different components of RTVS. RTVS actually consists of the Rational Integration Tester, which is the client tool. And on the server side, we've got the Rational Integration Tester agents. The agents are, in fact, the components that host all of the steps. Also, another component on the server side is a Rational Test Control Panel. And this control panel is, in fact, the main screen that allows you to control all of the agents, starting and stopping them, and any agents on any servers or feedback to the centralized central control screen. There's also a database that is accessed by both RIT and the agents, and it's called the results database, which basically records every single transaction that has been handled by the agents. It provides details about how the particular transactions went through the steps within the stops, whether it passed or failed, and what sort of request message it got, and also the response messages that it has sent back. This deployment we're looking at here is the deployment for the EVTE environment. And you may be able to see that in the EVT environment, we actually have 2 servers, each of them hosting an agent. And this is because EVT is a highly available environment, and the 2 agents is for redundancy purposes. RTCP, the control panel, sits on the primary server, which can control both of the agents. The results database sits on the database stack on another server. RTCP, RIT itself, a client tool, can connect directly to RTCP for the purpose of publishing the stubs. Once stubs are published to RTCP, you then use RTCP to deploy the stubs to the 2 agents. And in the EVT environment, it is the 2 agents are also balanced by an F5 load balancer. The request comes in from external software developers through the platform, the agency's platform, which then pass the request onto the F5 load balancer, and the load balancer would distribute the request to the 2 agents to handle the request and return responses. And because, as Andrew mentioned earlier, the protocols involved HTTP and MQ, MQ servers are also in this environment in a clustered configurations, and the agent connects directly to the MQ servers. How long did all that take? Time to value. So we embarked on this journey in June last year, and this is a journey as part of the entire transformation of the agency's platform. And our team, our RTVS team of 3 came on board around late July, early August. Throughout August, we learned the tool and built the first set of stops. Approximately 4 or 5 of them were built in August, and in September it was pretty much ready for the development team of the platform to start using. By January this year, we were able to deploy the first set of stops to the EVT environment. And throughout, from January to this date, we've had monthly drops into EVTE, introducing more and more functionalities of stops and keeping in line with the functionality of the platform and live systems as well. So at the same time, RTVS transactions have been frequent throughout the development and test environments. We've been handling RTVS transactions around several hundred transactions a week. In each environment, in the lower level environments, we've got 12 stubs running at a time. And just an explanation of how long it takes to build each stub. Basic level stubs, which consists of fixed responses or single response or just very basic scenarios, takes about 7 days for our average skill level. Extended stubs include things like logging timestamps, large or complex message structure, dynamic responses, and by dynamic, it could be responses based on certain values in the elements or evaluated response, or multiple responses. A single request may require different responses to be sent at different times. That takes approximately 12 days, and further advanced stubs would be stateful stubs, stubs that remember the response that has sent back the last time and send back something else the next time, stubs that handles repeating elements and pass through to live systems, or things that may require special message encoding and decoding. And on average, they take around 16 days to build. So what benefits have we gained? From our point of view, and because we see it day to day, the biggest advantage that we have given the agency is the benefits of continuous integration. We could see that throughout their development and build of their central platform, that they were able to have an integrated environment from the start because of the stubs. And as a result, there was a reduced number of SIT defects, system integrated testing defects. We were able to troubleshoot a lot of the shakeout issues before entering a fully integrated environment. The testers have reported they have been able to get more scenarios tested that they may not have been otherwise due to data constraints. And all of that results in cost savings. And the most obvious cost savings would be a reduced need for live system infrastructure, not just in EVTE, but also in SIT environments where they previously may have needed weeks or even months of SIT infrastructure. They've now been able to reduce that time frame because we can do a lot of that upfront, a lot of the shakeout tests and all that upfront thing, RTVS before entering SIT. And of course, the earlier detection of defects is definitely a cost saver in terms of time and effort. And as everyone knows, the later that we pick up a defect, the more costly it is to fix. This also provided them with a set of standards and centralized stubs. We had redone quite a few of their previously handcrafted stubs that were stored in various systems and turned them into RTVS stubs and improved upon them. Basically, they're now more flexible. They provide more scenarios and a more accurate reflection of the live system. We also use RTVS stubs to do component performance testing because of its capability to log timestamps. And finally, and most importantly for our clients, they're now getting a more stable EVT environment, one that more accurately reflects their live systems, and external software developers have been using it now. What challenges did we face? There have been quite a few challenges, and the first one is basically gathering information, and this is not something that's unique to RTVS itself. There's any time that you build a stub using any tool, you would need inputs such as sample messages, and for RTVS, that is the most important input, as well as whistles and schemas. And of course, the other functionality with RTVS is to be able to record live systems, live traffic, in order to pick up those sample messages. But that's sometimes in organization that is not easy to come by, and that has been one of our biggest challenges, finding the accurate representation of live systems by way of sample messages to be able to build an accurate stub that accurately reflects the live system. Another challenge is understanding the scenarios for 3 different user groups. As I mentioned earlier, we considered our user groups to be not just the external software developers, but also the developers and testers of the agency's platform. The tool has still been, as IBM had just recently bought Green Hat and transformed it into the Rational tool, it is still undergoing some changes, and so learning the tool, working with the Rational team to understand what new functionality has been introduced in the tool, and understanding its behavior, that was all part of the challenge, and that's mainly really due to the fact that we were new to RTVS ourselves. And version alignment, and again, this is not unique to RTVS, but an issue that does exist for test virtualization in general, is making sure that the stubs are constantly up to date with live systems. And this requires a bit of process and regimented process from the client side to make sure that they have a way of keeping these stubs up to date, of informing various groups when live systems change, so that we can keep stubs up to date with them. And the final challenge that we face, which we had been able to overcome quite successfully, is initial resistance or cynicism from basically people who are not familiar with the concept of test virtualization. And in the start, we've had these developers who had previously done handcrafted stubs come up to us and this live system is incredibly complex. It has all of these business rules. How are you possibly going to duplicate that? And we tried, and we had explained to them we're not duplicating it. This is a stub service. So and the tool is very capable of implementing these behaviors. And I think we have, over the course of months, as we delivered these working stubs, we've been able to convince them, and in fact the client now views RTVS as a very important tool for a lot of their project development. So the lessons learned, and there have been many. Firstly, all of these points is extremely important. The most important of all is the customer buying to this service virtualization concept, which often is a new concept to them. And once they understand what it is, it's important for them to communicate to all the various live systems and project teams that this is the strategy, this is their enterprise strategy in adopting service virtualization. having the right resources in our team has also been a key to our success. And as I said, the right resources are not necessarily developers. In fact, it's more important for the right resources of a stub building team to be very user-focused. And they do need to be a little technical, but they don't have to be serious software developers. Getting hands-on training from the start to learn this tool has been, of course, invaluable. And making and documenting architectural decisions from the start. This tool offers a number of ways in which you could build any stub. You could slice it any way you want. And the key is to make that decision in the beginning of general architectural principles or design principles based on which you would approach how you would design each of the stubs. And version control, particularly when we're supporting so many environments, oftentimes we may have different versions of stubs required in different levels of environment, and keeping track of those versions is very important. And then discussing with the customers about their process for interface alignment, because that is the key to keeping the stubs aligned with live systems. And also finally, once the customer has seen the benefits of test virtualization, it would be important to discuss with them a strategic vision of how they can further use this concept across the enterprise. On to the next slide. So where do we go from here? The customer is quite keen, in fact, to continue using RTVS for the upcoming phases of the project, and the next releases of the platform will require around another 15 stubs of extended to advanced complexity to build, and so we will be continuing to do that. But also the customer is keen to consider how to use RTVS in their other levels. Right now we are supporting their development and string tests and system test environments, but there will be significant benefits for them as well for us to extend the usage of RTVS to their performance test environment, as well as in their system integration test environment. We'll also be discussing with them about using RTVS outside of their e-commerce platform project and extend it to an enterprise level. They have other integration layers in the organization that could benefit from it. And finally, automated testing is another functionality provided by Rational Integration Tester. In fact, we're trying that out now, building automated shakeout tests so that each deployment, and this applies across all levels of environment for each code deployment, that we're able to run automated shakeout tests using RIT. So for more information on all of these things, here are some of the links provided. And I'm coming to the end of this presentation. So, Greg, I'll hand the presentation back to you.
Thanks, Ting Ting, and thanks, Andrew, for an informative discussion on an important and timely topic. We've now reached the Q&A portion of today's webcast. We do have a number of questions in the queue that we'll get to momentarily. I just want to remind the audience that if you have a question, to please submit it through our Ask a Question console. And now let's get to our first question. And this one having to do with the external software developers. And the question is, can you talk a little bit more about how external developers worked on the project?
Sorry, the question is how external developers work on the project?
Yes, exactly.
Well, the external software developers are, in fact, users of the platform itself. So to them, it's the fact that the stocks are in place in EVTE is transparent to them. They will submit the transaction through a front end to the platform. In fact, I will refer back to a slide earlier which shows, I'll just go back to slide number 14, which shows the platform and all the services that have been stopped. So you've got the external software developers on the far left who would submit a transaction, for example, submitting a form into the e-commerce platform in the middle. It would go through various components, SBR Core, one of the components, and then it would go through one of our stops in the middle called ISF. ISF actually performs some sort of ID injection into their request message. It then passes it on to EMC, the next component. EMC then submits it to another RTVS service, Access Manager. On the sort of right-hand corner of the blue box, there is Access Manager, which simulates a response back on the permissions that the software developers are allowed to perform, and then the EMC then passes the transaction through to one of the stopped backend systems. For example, the ICP application in the EAI layer, and ICP again as a sub-service would provide a response such as form processed or form successfully submitted, and that response travels all the way back through the platform to the software developers. So that is how the external software developers will utilize this.
Thanks, Ting Ting, for that. And moving on to our next question, this having to do with stubs deployment. And question here from the audience is, how do stubs actually get deployed onto the server, and what does the tool look like?
Okay, I'll answer that with a slide as well. We have a backup slide that shows what the tool actually looks like. And firstly, I'll show you this conceptual slide. And this slide shows a few of the components that I mentioned during the presentation, where you've got RIT, Rational Integration Tester, publishing stops onto Rational Test Control Panel, which sits on the server. And once it's on the server, using Rational Test Control Panel, we would deploy these stops onto the agents, and have as many agents as you want. And you can deploy the same stops onto multiple agents. So that is the deployment process. As to what the tool looks like, I will bring up this slide. So this is a screenshot of one view of the Rational Integration Testers. There are multiple views, but in this screenshot, you can briefly see a number of stops that has been built on the left-hand panel, and in the right-hand panel, or the central panel, you can see the input message that the stop expects, and there's also business logic and the output message that was sent back. And so this is basically what the stub building and publishing tool RIT looks like. And I'll show you just one more slide of what the control panel looks like. And so this is the dashboard of rational test control panel, showing all the stubs that are running. And through this control panel where the green plus signs are, that's where you could start and stop stubs, which is the deployment process. And so through this, you can monitor how many transactions are coming through, which agents are handling which stubs, are hosting which stubs, and so on.
Thanks, Ting Ting. And we have another question regarding stubs, and it's asking to go through an example of how stubs are used for a specific transaction. Is that something you can do?
That's something that I actually explained earlier from the first questions. And as I mentioned earlier, it was through the e-commerce platform, which like a transaction such as a process form would go through the platform and go through the sub in the back, and then sub return a response, which goes through the platform back to the users who are software developers.
Excellent. And in terms of the RTVS, is there a learning curve to pick up RTVS, and are there development skills that are required?
There is a bit of a learning curve to pick up RTVS, and in terms of development skills, you need to be a little bit technical, but not an experienced developer. So if you understand basic coding concepts of any of the coding languages, the actual if you do need to do any scripting within RTVS, the actual type of scripting is called ECMAScript. It should be just very basic scripting that you need to do, and if you have sort of basic coding knowledge, you should be able to pick that up. The learning curve is really about using the tool itself, and IBM does provide an online training course, and to do that, and IBM, I believe, is also developing some classroom-led courses that will help you basically learn the RTVS tool.
And so with this lead time in learning RTVS, what is the best way for an organization to create stubs quickly if that organization has a lot of short-term projects?
That's an excellent extension, Greg. Whilst most organisations will have some form of testing practice in place, we find that through the support of, let's call it IBM services and education programs, as well as a range of service providers, we can assist these customers with either specific project-based services or just straight educational processes. Now, that would be the first point of call to build out, let's call it competency in the technologies in use. But more than that, as an extension, we find that once the base service virtualization concepts are embedded within the organisation, that we see the establishment of centres of competency or centres of excellence to support the more broader outcomes at an enterprise level being more practical views. So we have small teams as Ting Ting's team in a specific company that would be created and tasked with not just the creation of the stubs, but also the maintenance and onboarding of further stubs as the individual projects come online.
And we have a question here regarding the building of stubs. Do you record live transactions to build stubs?
Thanks, Greg. That is actually a very common question because that is a key capability of any test virtualization tools. And ideally, you would record live transactions to capture accurate inputs like sample messages. For our projects here, it has been difficult to record live transactions due to the classified nature of the of production environment. So that is something that we rarely do in this particular project. We would like to. We have recorded live transactions in lower level environments in the past, but mostly we have been building stubs by using sample messages provided by the live systems themselves and with data from lower level environments. But yes, that is recording live transactions is definitely something that the tool can do.
And how do you keep the stubs aligned to live systems?
That is a challenge that we face still, and that relies heavily on the organization's own interface alignment process. So if the organization has a solid process in place, then it's just a matter of fitting in with that interface alignment process, and a centralized test virtualization team like ours would be informed or advised when live systems have been updated, and we can update stuff accordingly. But of course, that is the kind of process that needs to be discussed with the clients and with the organization, and to make sure that they do have those things in place. And that would be how you would keep stuff aligned with life.
And Ting Ting, in your presentation, you had mentioned that there was some resistance and cynicism from developers. How did you get beyond that developer cynicism, and was this a cultural shift that was required?
It was a slight cultural shift, and it was really more of an education thing. To many people, service virtualization is still a fairly new concept. So it's really showing them how we use RTVS and basically producing an outcome in the end. Once they see a stub in action, it was actually quite easy to win them over because they can see that it actually does work.
And we have another question here about stubs. Has the use of stubs made a difference in the length of the release cycle for this product?
I believe it has, so I can't quite quantify how quickly it has managed to shorten the release cycle. But we had been aiming towards monthly releases of functionality into EVT, which was previously not done at all, and it was going to be quite a challenging exercise to do that. But we've been able to meet all of the monthly drops and release new functionality into EVT. So I would say that using stubs had been key to that. If it was live systems trying to push monthly drops into EVT, that was going to be virtually impossible. So yes, I believe it has sped up release cycles.
Well, thanks again, Ting Ting and Andrew, for your participation today. We're going to have to leave it there. We've reached the conclusion of today's webcast. I want to thank IBM for sponsoring today's event, and I want to thank the audience for joining today. In addition, in the next day or two, we will be emailing to everyone a link to an archived version of this webcast so you can review it or pass it along to a colleague. For those that submitted questions that weren't answered today, you will receive a follow-up email. Thank you very much for attending, and this concludes today's webcast.